Welcome to the new lecture of C++ programming. In this lecture, we are going to cover the concept of a recursion in C++. Okay. So recursion actually means that a function may be called again and again by itself. Okay. So it means that a function will call itself in its body, and that can repeat unlimited time. Okay, so this concept is known as recursion. Okay, so how can we implement, or how it works actually in the C++ programming? So if you have a user defined function, for example, this is my function, user defined function, okay, and you have defined it before the main function, and in the main function you are calling this user defined function. So this is actually calling user defined function. So when execution comes to the user defined function, in body of this function is going to call itself again. Okay, so what will happen actually, the execution will come back to the start of the function, and it will repeat the execution of its body. So this concept is very similar to the concept of the loops as well, where the loop actually iterates its body multiple times, depends on the condition. Okay. So this concept, this is now recursive call. So it means that the function will call itself in the first execution, then the execution will come again to the body, and then the execution again will call itself for the execution. So this execution of the of the body of the function, of the user defined function, again and again is known as recursion in the C++. So let's see an example, how can we fit this recursion in the real life problem, where we can actually implement the recursion concept. So let's see. Here you can see that we have introduced the factorial function. Factorial has return type the integer, and in the parameter list we have only a single parameter which will accept a single integer value. Okay, so for that integer value we will find out the factorial using this function, the factorial function. So this is the prototype of the function. This is the prototype of the function, and here we have defined the main function. In the main function, we are going to call this factorial function with an integer value 4. It means that we want to find out the factorial of 4 by calling this function. So we have the definition for this prototype is here. This is the definition for this prototype. Okay. Now in this definition we have included a variable of type integer. Okay, so in prototype you don't need even to declare variables, okay, in the parameter list. You just need to mention the type of the variables. Then in the definition you shall introduce the variables with the relevant or respective data types. Okay, so here in this function you can see we are actually receiving the argument in integer a, which is parameter a. Okay, and that parameter and that variable actually is checked here in the condition that if the value of a is greater than 1, then we shall call the factorial function. Okay, so it means that then we are going for the recursive call. Okay, so in this way we are creating a loop, just like the loops concept in the C++. So if the value of a is not greater than 1, it means that the value may be equal to 1 or less than 1, then what should it return? It should return the value 1. Okay, so let's see and check the execution of passing 4 through this function. So the factorial function will be called recursively multiple times, so we need to visualize it. Okay, so actually these slots represent the calling, recursive calling 1, okay, then recursive calling 2, then recursive calling 3, and then recursive calling 4, okay. So when execution start from the main function, so from the main function we will pass 4 to the factorial function. So what we will see in the factorial function is that 4 is greater than 1. Yes, the condition will become true, and the value of a here, of course, is 4. Okay, 4 multiplied by factorial of a minus 1. Four multiplied by factorial of 4 minus 1. So it means that we are calling the factorial function again, okay, and the return is not executing yet, okay, because we are going to call the function. So when function execution is stopped, then the return statement will return the answer of this multiplication formula, okay. So in the first calling, we are going to execute the value of a is 4 multiplied by factorial 4 minus 1. So in the first calling, we are passing here value 3 to the function, okay. It means that we are executing the function, the user defined function like this. 4 is coming through this path, okay, through this condition, and then condition is becoming true to execute this whole statement, okay, this whole statement. And this statement is going to call the itself function, again by executing the formula as the values are given here. 4 multiplied by factorial of 4 minus 1. So 4 minus 1 is equal to 3. So therefore we will see that 3 is passing as argument to this function. Now 3 is coming through this path, okay, and if 3 is greater than 1, so it's obvious that 3 is greater than 1, so condition will become true and this statement will execute. So here you can see the formula is a multiplied by factorial into a minus 1. So this is the second recursive call where the value of a is 3 multiplied by factorial 3 minus 1. Okay, this is 3 minus 1. So we are going to call factorial function again with value 2. Okay, so 3 minus 1 is equal to 2. In this way, this function again with value 2. So 2 is coming through a, and 2 is greater than this body will be executed. So 2, if we put the 2 as value of a, so 2 multiplied by factorial of 2 minus 1. So this is now the third call, and third call can be written as, so this is the arithmetic operation, and this arithmetic operation will be executed first, so it will return as 1. Okay, so in this way we are going to call the factorial function with argument 1. So it means that we are going to call the function again with value 1. Okay, so 1 is coming here, the condition is checked here. So 1 is greater than 1? No, 1 is not greater than 1, so therefore return 1. Okay, so in this calling, in the fourth calling, we are executing the return statement 1. this statement will be executed. Okay, so when this statement is executed, so it means that in the fourth recursive call there is no recursion more to be executed here, because we are not calling the factorial function in its body anymore. Okay, so the execution will stop here, it will return 1. So this return statement will return 1 to the third recursive call. Okay, so it means that we will see the answer of this factorial function is 1. Okay, so this one will be multiplied with 2. Okay, and 2 multiplied by 1 will be returned. This is the return statement. This statement, the answer of 2 multiplied by 1 will be returned to the second recursive call. Okay, so the answer of 2 multiplied by 1 is 2. It means that this function is going to return 2. Okay, so 2 multiplied by 3 through return statement, so the answer is 6 actually. So 6 will be returned from second recursive call to the first recursive call, and 6 will come here as the answer to this recursive call, to the first recursive call. Okay, so 6 multiplied by 4 is equal to 24. 24 will be returned from the user defined function, and the answer that we will see here is return will be 24. So the factorial of 4 will be 24, and that 24 will be printed out on the console screen. So in this way you can see here that we have implemented the recursion concept of calling a function by itself in its body again and again, and we have actually controlled this repetition of the recursive calling by putting a condition, just like the loops, the concept of the loops in the C++, where we need actually now the condition to control the repetition of the iteration of the for loop. So the similar concept has been implemented here. We have used the recursion concept. Through recursion we are calling the factorial function, the user defined function, again and again in its body. Okay, and we have controlled the iteration of the recursion calling by putting a condition. Okay, and through this condition we are going to solve the factorial problem, which is the real life or real world problem. Okay, and we will get the answer through single calling from the main function. So if you have any question regarding the factorial or the specifically to the concept of the recursion, so please ask me in the comments below. Thank you so much for watching this video, and see you in the next lecture. Thank you.